All right, so today we're going to do a deep dive into something that you might actually be learning in class right now if you're, taking a computer science class.
Right.
We're going to look at 2D lists on Python.
Sounds good.
And we're going to go through this resource that we found that gives a step-by-step guide for building the classic game concentration, sometimes called memory.
Yeah, it's a really cool resource because it takes that theory that you learn about, how these data structures work and actually puts it into practice.
Yeah, exactly. So it's more than just here's a 2D list. It's like now let's actually build something real with it that you can play.
Yeah.
So our source material is focused on using Python to write board games.
Right.
And the concentration game is a really good way to illustrate how 2D lists work. So if you've been struggling with like rows and columns and all that stuff, this is a really, really engaging way to see how they're useful.
Yeah.
So, if you're thinking about like, okay, how do you even begin to think about writing a game like this with code?
Yeah, where do you even start?
Where do you even start?
With this particular game, the first thing you need is a game board.
Right.
And as our source material points out in what it calls checkpoint 1, the natural way to represent that grid, kind of that game board shape in Python is with a 2D list.
Okay.
And they've created one here, and they're calling it app.cards.
App.cards. So we can kind of imagine a list, and inside that list are other lists. It's kind of like rows and columns in a table or a spreadsheet.
Right.
Our source mentions setting app.rows equals 3 and app.calls equal 4.
Yep.
So we have a 3x4 grid.
Exactly.
So that would be 12 cards total.
That's right.
But at this very beginning stage, like what exactly is stored in each of those, spots in our app.cards 2D list?
Yeah, so that's a really good question.
Yeah.
And initially all it is they draw a grid of gray rectangles. And so the function that is responsible for doing that is called initialize cards.
Initialize cards.
And it uses what's called nested for loops. So one loop inside another to go through each row and then each column in that 2D list.
Okay.
And for each spot, each position, it figures out, okay, where should that be on the screen?
Right.
Like what are the XY coordinates of that? And it creates what's called a rect object, which is basically just a rectangle shape.
Okay.
At that spot. It's 60 pixels wide, 80 pixels tall, and it's filled with dark gray.
So it's like literally drawing that gray rectangle.
Yeah.
And it's doing that for every single spot in our 3x4 grid.
That's right.
Okay, so if we were to like peek inside that app.cards 2D list at this really early stage, we wouldn't see like numbers or text or anything like that. We would just see those rect objects.
That's exactly right.
Like the building blocks, the visual building blocks.
Yep.
That's interesting how they use those objects, right in that 2D list.
Yeah, it's a cool illustration of how you can use this data structure to actually map to things that you see visually.
Yeah.
So that initialize cards function, it takes those dimensions that we set, with app.rows and app.cols, and it uses that to just, populate that list with all of those rectangle objects in all the right places.
So it's like setting up like the board.
Yeah,
like setting out the cards before you start a physical game.
It's like putting down all the face down cards.
Okay.
So you've got your grid.
We've got the 12 empty gray cards.
Right.
But concentration's not very fun if they're just all empty.
Right. We need matching pairs.
We need matching pairs.
Yeah.
So what's the next step in making this playable?
So that brings us to checkpoint 2 in our source material.
Okay.
Which is adding the hidden colors to the cards.
Okay.
And the challenge here is to give each card a secret color and make sure there are exactly 2 cards of each color, all placed randomly on that 3x4 grid.
Okay.
And our source material is using this list of colors: red, light blue, blue, orange, pink, purple.
Okay.
And you'll notice there are 6 colors there.
Yep.
And we need 2 of each.
Right, because that makes 12.
That makes 12. So it fits perfectly on our grid.
Okay, so we've got our set of colors. We've got our app.cards 2D list with all the rectangles.
Right.
How do we assign those colors but keep them hidden from the player?
So the way they do this is with a function called setColor.
Set color.
And this function is called twice for each of those colors in the list.
Okay.
Which is what guarantees we get the matching pairs.
Oh, I see. Okay.
Right.
Interesting.
Yeah, so inside the function, the first thing it does is it picks a random row and column.
Okay.
And now here's where using that 2D list gets really clever.
Okay.
It uses a while loop
Yeah.
to check if there's already a card in that position. So basically, if you imagine trying to place all these colored cards randomly, you pick a random spot. And if there's already a card there, you got to pick a new random spot.
Oh, that makes sense.
Right. And so they do that in the code by checking if app.cards row call is not none.
Okay.
So if that's true, if it's not none, that means there's already a colored card in that spot.
Oh, I see. Okay.
And so the while loop keeps going until it finds an empty spot.
It's like it tries to put a card down and it's like, oh, there's already a card here. And it's like, let me try a different spot.
Right, exactly.
Okay, this one's empty.
It's like it's feeling around. Yeah.
Okay.
And so once it finds an empty spot, then it creates a new rectangle object at the correct coordinates.
Yeah.
But this time, it sets the color.
Oh, yeah.
To that color from the list.
Uh-huh.
And then, importantly, it also adds that color as what's called a custom property to the rectangle object.
Oh, okay.
And it's calling it r.color.
So it's like a secret label or something.
Yeah, it's basically like, if you think of it as a physical card, it's like writing the color on the back of the card.
Okay. Okay.
So you can't see it unless you flip the card over.
Got it.
And then finally, just like before, that rectangle object with that hidden color property is then put into the 2D list in the right spot.
Okay, so by the end of this this stage, like the app.cards list is full. It's got all the rectangle objects. They look gray on the screen.
Right.
But they've also got like a hidden color, a secret color.
Yep.
Okay. And it's all organized in, our 2D list.
Exactly. So now we've got all the information we need for the game.
Yeah.
We just need to make it so we can actually interact with it.
Okay. So far we've been setting up like the visuals and the data and all that stuff.
Right.
How do we actually make it so, like when you click on a card, something happens?
So that's where checkpoint 3 comes in the source material.
Yeah.
And this is about making the cards respond when you click on them.
Oh, okay.
And so this involves something called event handling.
Okay.
Specifically, handling mouse clicks.
Mm-hmm.
And so the code introduces what's called an on-mouse press event.
Okay.
And so when you click somewhere, that event triggers, and it calls a function that needs to figure out, okay, did you click on one of our cards?
Right.
And if so, which one?
Okay.
And that's the job of a function called findCard, mouse X, mouse Y.
Find card.
And this function, it goes through each of those rectangle objects in our 2D list.
Okay.
And for every card, it checks, okay, are the coordinates of your mouse, mouse X, mouse Y, are those inside this rectangle?
Okay.
And it does that using a method called card.hits, XY.
Card.hit.
And if it finds a card, that was clicked on, then it returns that card object. So it tells us, okay, this is the one you clicked on.
So now the game knows which card you clicked on out of our 2D grid.
Yeah, exactly.
Okay, so what happens once you've clicked on a card?
So back in that on-mouse press function,
Okay.
once we have the card, assuming we clicked on one, there's a crucial condition.
Okay.
And we check two things. First, did we actually click on a card?
Okay.
So card, none.
Okay.
And then second, is the current fill color still that original dark gray?
Okay, so it hasn't been flipped over yet.
Yeah, exactly. It hasn't been revealed.
Got it.
So if both of those are true, then we update the fill color of that card to its hidden color.
Ah, okay.
Which we, conveniently stored earlier.
Our color.
Our color.
Yeah. Okay, so that's how it visually flips over. It's like, okay, now instead of just this gray rectangle, it shows the actual color.
Exactly.
That's pretty cool.
And it's reaching into the 2D list, finding that object, and then accessing that hidden property to change how it looks on the screen.
Yeah. And it's interesting, if you're thinking about 2D lists.
It's not just like storing data.
Right.
It's like you're storing data, but then you can use that data to like do things in the program.
Exactly. Yep.
So in this case, it's based on user interaction. It's like, okay, they clicked on this, so now we have to change this.
Yeah.
Okay. So now we have to think about how the game remembers which card you clicked first.
Right.
Because in concentration, you click one, then you click another.
Yeah.
So how does the code keep track of that?
So that's where two new variables come in, app.firstCard and app.secondCard.
App.firstCard, app.secondCard.
Yeah.
Okay.
And initially, both of these are set to none.
Oh,
which just means, they're empty.
nothing's assigned to them yet.
Yeah.
Okay.
And then back in our on mouse press function, after
Mhm.
we figured out, okay, which card did you click?
Yeah.
We check first, have we already clicked a first card in this turn?
Right.
And if app.first card is still none.
Then it means, okay, this is the first card.
Okay.
And so we take that card object and assign it to app.firstCard.
Okay.
And then if app.firstCard is no longer none, meaning, okay, we already have a first card selected.
Okay.
And app.secondCard is still none, meaning we haven't picked the second card yet.
Okay.
Then the card that we just click becomes app.secondCard.
So it's like those first card, second card variables. They're just kind of holding on to those cards.
Yeah, they're like temporary storage, like temporary variables, just to hold those cards while we look at them.
So it's like pulling them out of the grid so we can, examine them.
Yeah, exactly.
Oh, okay.
And so now we know which two cards have been clicked on.
Right.
And so the next, really key step is to implement that logic of, okay, do those cards match?
Right. This is where the game gets fun.
Yep.
It actually has to decide, did you get a match or do you have to keep going?
Exactly. Yep. So that's what our source material calls checkpoint 5.
Okay.
It's implementing the matching logic.
Yeah, okay.
And the first thing they mention here is that, to make it so that those two cards stay flipped over for a second.
Right.
Before the game checks, they set app.steps per second 1.
Okay.
And this is controlling how often a function called onStep gets executed.
Okay.
And so in this case, it's going to get executed once per second.
Once per second.
Yep.
Yeah.
And then inside that function, the game checks first, is app.secondCard not none?
Right. So have we actually clicked two cards?
Yeah, exactly.
Okay.
And we flipped over two cards.
Okay.
And if so, then it compares the fill color of those two rectangles.
Okay, so if they're the same,
If they're the same,
that's a match.
that's a match.
Okay.
And so in the source material, it says that they indicate that visually by making the border of both cards green. Yeah. So, the player gets that feedback that they got it right.
Nice.
And then if the colors don't match,
Yeah.
if it's not a pair,
Right.
then it resets the fill color of both of those rectangles back to dark gray.
So it flips them back over.
Yeah, it flips them back over.
Okay, so after the game checks for a match or a mismatch,
Yeah.
does all that,
Right.
what happens to first card and second card?
So after the check, no matter what, whether they matched or not,
Yeah.
both app.firstCard and app.secondCard are reset back to none.
So it clears them out?
Yeah, it clears them out.
Okay.
And so now you're ready to click two new cards,
Yeah.
and the process starts all over again.
So it's like resetting for the next turn.
Exactly.
Okay. Our source also mentions briefly how the game ends.
Right.
The win and loss conditions.
Yeah.
So how does that tie into all this stuff with our 2D list?
So the game is won, once all of the cards are no longer dark gray.
Right. So you found all the matches.
You've matched everything up.
Okay.
And so there's probably a check win function in the code that goes through that 2D list and checks, okay, is every single card in here
Right.
something other than gray?
Okay.
And then the loss condition that they mentioned is a timer.
Oh, okay.
So the game probably starts with a certain amount of time.
Right.
And as the game progresses, every time the onStep function runs,
Right.
the time goes down.
Okay.
And if the timer reaches 0 before you've matched all the pairs,
Okay.
then you lose.
Okay.
So those are the two basic ways the game can end.
So from that very beginning of just like setting up a simple grid, using a 2D list, to making it interactive, revealing the colors, tracking the player's actions, like the whole game logic,
Yeah.
all of that uses this 2D list.
Yeah.
That's pretty cool.
Yeah, it really shows, we started with that fundamental structure
Yeah.
to represent the board.
Yeah.
We filled it with those, visual card objects.
Yeah.
We stored hidden information within those objects.
Mm-hmm.
And then, we used the 2D list to easily find and modify specific cards based on the clicks.
Yeah.
And then ultimately, that information in the list is what allows us to determine, okay, did the player win or lose?
Right.
So it all comes back to that, that organization of data in a two-dimensional way.
Yeah. I think what's really cool about this is, it takes this concept of a 2D list,
Yeah.
which can seem kind of abstract when
Oh,
you're learning it,
yeah.
But it shows you how you can actually use that to build something
Yeah.
that's fun, that's engaging.
Yeah.
And it's not just, storing data.
No,
It's like
no.
you're organizing it in a way that makes sense
Yes.
for a game board or for other applications.
Yeah. Yeah. And it's really efficient too, in
Mhm.
terms of being able to access the information and modify it.
So for you listening, especially if you're just getting started with 2D lists,
Yeah.
think about how you could apply this to other things.
Right.
Even beyond games.
Yeah.
What other kinds of games could you imagine building using the same basic idea?
Yeah, or even just, we're representing something like a chessboard.
Yeah.
Or even just, a simple spreadsheet of data.
Right. Right.
Understanding how to use those 2D lists really opens up a lot of possibilities for organizing and
Yeah.
working with information.
Yeah, that's a great point. So as you're working on your own projects, whether they're big or small,
Mhm.
consider how you might be able to use a 2D list to help you out.
Yep.
It's a really, really powerful tool.
It is.
Well, thanks for taking this deep dive into building concentration with us today.
Yeah, thanks for having me.